All right, welcome everyone. It's just turned 4, so I think we'll get started so we have enough time to get through this. We're here today to talk primarily about using R in the context of ArcGIS, but also some about data science and how it relates to using R. So my name is Shaun Walbridge. I'm a developer in the Geoprocessing team. I primarily work in Python, but I also am doing a lot of work now with R. And this is Marjean.
I am Marjean Pobuda, and I am a product engineer for the Spatial Statistics team, and I also serve part-time as product engineer for the R ArcGIS bridge.
Great. So we're going to go through a lot of stuff here, and if you've been to a talk that I've given before, you've probably seen this already, but basically that very top URL there is the slides that the slides that we're looking at right now are at that URL, so feel free to follow along. Also, you can write down that one URL. There's lots of links in this talk. I find it much easier than trying to have everyone furiously write down links and spell them out. Just give someone the slides. The second link here, this GitHub repository, is the slides themselves and also any demos that we're going to give. There'll be resources in there for that. They're not all there right now, but we'll get them up there in the next couple days. Those are two good starting points. I'll let you take a picture of that. There's also a resources section in this talk. We used to have 75 minutes for these sessions, and now we only have an hour. So instead of talking like the Micro Machines man, I'm going to probably just not talk through the resources section, but leave that to you as an exercise after we're done today. But if we do have extra time, then I will look over that a little bit and just give you a little bit of flavor of some good next steps. Okay. So, all right. So, what is data science, right? That's a good starting point. So, yeah, it's pretty high. There's this idea of like a hype cycle you might have heard of, and it's pretty much at the top of that hype cycle right now. I'd say it's somewhere around peak hype of data science. But what is it really about? It's taking things we've had for a while and combining them in a new and interesting way, right? It's about taking statistics, which has a long history as a discipline, and machine learning, which is newer. Machine learning has gone through a number of different evolutions. Some people would classify it as a part of AI. There's some labels in the scientific community that they come and they go because people have to write new and compelling grant proposals, and certain labels are not, they're not acceptable in certain communities. So sometimes labels go away. AI is actually one of those ones. There was something called the AI winter in the 80s, and you could not get any money for AI. So I think machine learning kind of took the mantle as that name, and now it's kind of making a comeback now that data science is getting bigger again. But the basic idea is that you're applying those two domains, statistics and machine learning, to real world data. You're not just doing it in the abstract, you're doing it with real world data, and you're coming up with formalized methods that take that data in some kind of pipeline that you can use and reuse, right? So you're not just doing this once, getting one published result, you're doing it for some system where you can use that result over time. So it kind of maps well into how we think about doing things in a business process context, right? We want something where we can change the process, but then we can continue using that many, many different times. Now doing that, transforming this where you're going from doing a one-off analysis into this kind of formalized tool, takes a lot of different fields to get us there. So there's a lot of people with they're bringing different aspects of the story to data science. So, this is what is a data scientist? Josh Wills, he's a Cloudera. He was here a few years ago at Dev Summit. His definition of a data scientist is someone who is better at statistics than any software engineer, and better at software engineering than any statistician. And it's a pretty good, I'd say it's a pretty good working definition. The joke version of this is a data scientist is a statistician who lives in San Francisco. Those are, we can go with either of those, but, just to give you an idea, it's someone who is kind of combining these two, what historically were pretty disparate environments, creating statistics and actually doing software engineering, right? So data science has an interesting context in geography. There is kind of this nascent field of spatial data science. We already, as geographers, have to rely on knowledge from many different domains, right? Geography is often an enabling discipline. It's not working in and of itself, right? It typically is combining with other domain knowledge to solve problems. We know that spatial data is more than just taking the X column and the Y column and saying, all right, we're done, we've got spatial, right? We know that we can do certain methods, even though it's just If you have just an x and a y, it's just two more floating point values in a table. We know that actually just having those two floating point values have a very special context and special meaning that we can get a lot more out of. So part of what I think geography brings to this is we can take that same data and contextualize it. Maybe it's been historically just done in an aspatial context. We can textualize it and we can do new and interesting things that combine both geographic science and some of the data science stuff that's going on. So in terms of languages that people use for data science, there's a lot of them. I'm just going to kind of give you a quick background on it. There's a lot of different things going on. Python has a big community. C++, Java, some of the more heavyweight languages do. R, we'll talk about a lot today. One thing that's interesting is that I mentioned how it's kind of converting these workflows into productized systems that are reusable. That often means that you have to take pieces from different stacks. You can't just say like, we are a Java stack, we're a Java shop, and we're only going to do Java, and if there's not Java code to do it, then we're not going to do it. That's really, it's impractical in a lot of situations. It's very common that a data science problem requires spanning multiple languages, and it's part of the reason why we're looking at things like R is that we want to meet people where they're at. They need to access things in different environments. I just did a quick, there's actually this recent report that came out from this blog, R for Stats, and this is a report on the data science job world, just produced maybe a month ago now. And it basically looks at the jobs that are labeled as data science. What are the programming languages that they use? SQL, I mean, it's kind of arguable whether it's a programming language or not, but it's definitely the top, it's the king, right? Everyone has SQL somewhere in the back of their systems. I put some check marks here for the things that Esri has supported for some time, right? Those are things that are part of the core product. So, SQL, you probably use that, Python, Java, Hadoop, C, C++. We have a bridge for integrating with SAS. But there's kind of one missing from that top, right, which is R. So that's what we're here to talk about today, about R. It's clearly used in a lot of data science contexts. 2 years ago, Esri didn't have any story for that. One thing I also wanted to mention is in this kind of framework where you are trying to combine things from many different languages, one of the problems you have is how do you actually get all that software into the environment you're interacting with? Well, we've partnered with this company, Continuum Analytics, and they're really, I would say they're kind of the preeminent provider of open data science solutions. So they've built an open source industry standard package management system called Conda. It initially came out of the scientific Python community. A lot of the folks who work there are some of the founders of that community. But they, as Marjean showed in her really great demo in the plenary, we can use it for doing things packaging up R as well. And we can use it actually for lots of other languages. And it kind of gets us closer to this idea that we could create some environment where we have a workflow that spans multiple different languages at once. If you're interested in learning more about what Continuum's doing and some of the offerings they bring to the data science table, they have a session tomorrow at 10:30 in the morning in Mesquite, GH. And Brendan Collins, who's a great guy, and he knows a lot about their offerings and about the spatial world. He's going to be talking about some of the stuff that they're doing today. Okay, so let's talk a little about R. We've kind of identified why R is interesting to us today, but what is R? What is it for? So Esri has, it's been doing a number of things to get into the R community. We've built this R bridge. We're going to talk primarily about that today. We're also doing things kind of at the logistical level, right? R is open source language, and it is contributed to by many companies and many individuals. So we've joined the R Consortium, which is kind of a collective interest group of companies that have some interest in making R and do new things. They do some cool stuff, like they take money from various companies like us and many others, and they then give it back out to community projects. So they identify interesting new projects and hand that money back out to extend R in different directions. We also are doing a lot of other things. Historically, GIS has been more purely Python, but we're trying to meet people where they're doing their analysis. Okay, so what are the things that make R really great? One thing is that it has data structures and operations that are very useful for statistical analyses. It really came out of people needing to do statistical analysis as a programming language and environment. And that means that the things that are in the core of the language are things that people who need to do some kind of data analysis, they want them. And it's built in at such a fundamental level that some things that in other languages are just possible but very painful are instead very simple in R. And there's a few things, we'll talk about some of those in detail, but these are things like data frames, the functional programming model that it uses. But there's also some other stuff it does. It has some things called DSLs that it implements, and we'll talk about a little bit of that as well. It also it's really kind of snowballed into being the de facto language of statisticians, and that's across a lot of different domains of statistics. My background's in ecology, and most of the kind of big, well-known ecologists actually produce packages first. They produce R packages. That is the output of their scientific research. They publish papers based on packages they've published. So that's pretty powerful. If you need cutting-edge statistical routines, then you can't do better than getting a stats package from someone who just created it, and it's very on the edge of what's possible. So there's about 6,400 packages on CRAN, which is the package repository. Now those vary greatly in quality, right? There's just requirements like you have to make this thing fit certain things, but there's no like formal rejection process, right? So you have to do, one of the challenges is you have to do a little bit of work finding the right package for solving your particular problem. Also, R has really great and very versatile plotting. So you can make really great publication quality plots, and it's actually pretty simple to do. And I think its plotting remains, even though there's lots of new things happening in the visualization space, it remains probably the best plotting solution out there, particularly if you care about the meaning of the visualization, right? It's different if, sorry, I'm getting a little feedback. It's different if you're just trying to make like a chart to put in, I don't know, some meaning somewhere, and how it gets interpreted isn't exactly, it's just like, is that bar bigger than that bar is the answer? That's fine, but sometimes you actually really care about that every like pixel in the output is going to be rendered in a special way so that you can interpret it directly, right? There used to be this game of academics taking papers where they wouldn't publish their data, and they would then like digitize, extract the PDF and then like get the relative heights of the different charts and the bars, and then they'd convert that back into numbers so you could get data out of the paper, right? R would be a good place if you want to do that because you actually would have very accurate plots. Okay, so we're gonna talk a little bit about programming in R, so we have to assume a very basic proficiency in programming for this talk. We also have some resources for really getting into the guts of R at the end of this presentation, right? So we're gonna just talk about the basics, get into this R bridge and how you can interface it with ArcGIS. But if you want to learn more about R, about the programming language, check out the resources at the end. So, what are the data types that are at the bottom of R? Well, most of them are things that if you've done any programming, then you've probably seen them before, right? They're things that are common across all the different major programming languages. Things like we have numbers, right? We have numbers that are floating point numbers. We also have integer numbers. We have strings, which are characters. We have Boolean values, logicals, and we have times, right? Those are things that pretty much any programming language is going to provide you because they're so commonly useful across different environments. But the differentiating factor in R is that you get a bunch of things in the language at the very core that aren't available in your typical programming language. Some languages have these maybe as extensions, but they're not necessarily well integrated into the language, and you can't rely on them existing wherever you're doing your code, so it can be very tricky to implement them. These are things like matrices, right? And the simpler case of a vector. Data frames we'll talk about a little bit more. And there's also this idea of factors. So if you had like some ordinal data, you might want to store it in a way where you have like a lookup table where you say, well, there's only like 4 levels in this factor, and then you can reference it in a numeric context or through the textual value. So it has all that stuff right baked into the base of the language. Data frames are a particularly interesting thing, so I'd like to highlight them, and it's something that I really, really like. Basically, the idea is that you store your data. It could be just tabular data, but it also could be multidimensional data, and you store it in a way in which all of the variables that you're capturing are labeled specifically, and each observation you have is indexed. So you can think of you got some kind of table or matrix, and you've got your different labels for the different variables you're capturing, and then each row is indexed, and that tuple, that one row, represents a collection of there's some related observation. They're all part of one observation, and you can then get to them either through the index or through the labeling. Now, it sounds pretty simple, but it actually is a much, much better data model for doing analysis than what existed before it, right? Excel, I mean, I like to bag on Excel. Sorry if there's anyone who uses lots of Excel for interesting things, but it's really hard if you have someone else's Excel data and you want to work with it, right? The guy who designed VisiCalc, which is the intellectual predecessor to Excel, he said, well, it's really just a 2D layout program. It's not actually doing any real, it doesn't know about typing information, for example, right? So you could have easily like a column where you think you get nothing but 64-bit integers or floating point values, but actually, you know, someone puts a string in there. And then you have to do all this work to kind of parse it out. You can't really work with that at the base because your data structure is conflating things. It just lays out things in 2D. And the fact that you can sometimes sum them correctly doesn't mean that that's a good data model for storing all your data fundamentally. So the thing that's great about, I mean, that's why I love data frames. I'll now walk you through what they look like in R. So in this case, I'm just going to take a very simple CSV file, something you might have sitting around already, and I can just tell R to read that file. I'm pointing it at the name of the file, and then I'm telling it this particular CSV has a header row, right? We've already labeled our columns with a header row. And now at that point, I have this data frame that's come from my CSV file, and I can do things with it. The other way of making data frames is that you can concatenate together existing objects. So here I'm defining these vectors. So vectors are, you know, some stored collection of the same data type. And in this case, I'm going to put together some information on the quarter of the year, some people names. I've got some famous geographers here, Goodchild, Tobler, and Kriege. And then I've got this and for some reason in this scenario, they're salespeople. I don't know why, that doesn't really make any sense. But they're salespeople, so I'm going to store whether or not they met their quota in the particular quarter that we're looking at. And it looks like that Tobler failed. He probably was making some other really cool observation instead. But okay, so now instead of making a data frame by pulling in data, I'm going to concatenate together these different labeled variables into a data frame. So all I do is I point it at the 3 variables that I've created, and now I'm going to get out of that, again, a data frame where the labels are going to be shown as the variables that I input. So if I then just type df at the R prompt, we get this representation, right? We've got our labels here, and we've got our observations, our indexed observations here. So that's the index here, this numerical index is getting assigned automatically, right? And if you come from like a database world, you could think of that as being like a unique primary key, right? It's automatically generated for you, and it always keeps track to make sure that the data is never ambiguous. Okay, we also have in R, that's kind of the very basics of some data types in R. We also have some spatial data models. There's a package called SP, and it knows how to deal with some pretty complicated representations of data. You know, the first 3 here we're probably all familiar with, we probably work with pretty commonly, which is the 0, 1, and 2-dimensional case are points, lines, and polygons, right? We probably all work with that a lot. SP actually even knows how to deal with more complicated models. It can deal with solids and with space-time objects. You know, now whether you could do an analysis of space-time objects can, you know, it's more complicated. There's not as many tools that know how to take that and do analysis on it, but you at least can represent it very simply in R. Now, the general story here is the entity attribute model, right? So if you've dealt with spatial data before, this is what you're used to, right? You have like some tabular data structure that represents the attributes that you're storing. And then on the side of that, you have the entities, right? The geometries themselves. And there's some linkage between those. You don't want to store, in the simple case of points, you actually could store, right? You can kind of cheat. You can just put an X column, a Y column, and then you're done. But in any of the other cases, you need to kind of link those 2 views together because the lines and polygons, they're not going to fit nicely into that tabular structure you have. They might have totally different sizes and scales. And this is a common model we use all across GIS. It's also implemented in R. Okay, so now I'm going to get you into the actual R ArcGIS bridge. And just as a little bit of a background on that, so who are we targeting with this? Well, one thing that we found in talking with a lot of our customers is that they often have a lot of different people in their organizations, right? They have some people they're often responsible ultimately to talking to stakeholders. And the stakeholder group is often very large. It could be the public, say if you're working at a local government, but it could just be internal stakeholders too, right? But there's often a lot of those stakeholders. But they don't necessarily, they're good at maybe taking results and interpreting them, making alternate decisions, but they're maybe not in the business of generating new results, right? And then they have analysts who, that often might be in the spatial department, it might be in other areas within their company or group, but they have very solid problem-solving skills, often very solid spatial reasoning skills. That doesn't automatically mean that they're programmers. And there might be a few people in the organization who are really, very, very fluent in programming. There might be some people in that organization who only do programming. Now, the ratio between these different classes varies between different organizations, but we have customers where this ratio might be as large as 1,000 to 1. For every highly fluent R programmer, they might have 1,000 analysts in their staff. So that creates a mismatch, because if there's a limited number of these people who are really, really fluent in R, it might mean that anytime anything comes up that an analyst can't handle, they have to throw it over the wall to the programmer, and it's kind of a bottleneck, right? There's some problems there. We also want to enable the analysts in the organization to do more and to take advantage of some of the things in R without having to necessarily learn soup to nuts the entire language. So that's one of the motivating factors behind us creating this bridge. So just to kind of reiterate that and also think about it in another context, we've got some ArcGIS developers, and they already know how to do things like create tools, make toolboxes. They want to do that in a way they can integrate R into the existing workflows they know and understand. And for users of ArcGIS, they might want to have, maybe their organization, or maybe they got it from somewhere on the internet, there's some R code out there that does exactly what they want. They want to implement it in a way that just can be used in the context they know and understand, which is something like a geoprocessing script. And finally, there might be R users who maybe they don't use ArcGIS at all, they're not really maybe even interested in it, but they might be in a situation where their organization's data, the system of record in their company or group, is already ArcGIS. And so if the end result for them is they have to spit out data into some other format, and it has to go through some kind of munging process to get it back in, that's problematic, right? Because it means that ETL transformation is kind of broken. So they might be able to want to get into the organization's data, do analysis in R, and then put it back into the system of record, managed in the traditional GIS ways. So that's kind of the motivating story behind the bridge. So what it basically does is it lets you do some of those problems. It lets you take your data in ArcGIS, store it using the ways you always have, access it quickly in R, and then return it back at the end as R objects that get converted into the native ArcGIS data types. So this could be things like feature classes, it could be other kinds of things as well, tables. And it also knows how to, we mentioned that SP package, it knows how to take the spatial data you have and convert it into a native representation that R understands. So I just linked here to the package documentation, and with that, I'll let Marjean take over and get you into showing you actually how this works first.
Awesome, thanks, Shaun. So really the point of this demo is just to help you get your feet wet here. We're gonna start by showing you exactly how you get started, how do you get this infamous bridge, and just a basic example of how you can use it to read and write data from ArcGIS to R. So to begin with, we start here. If you are to just Google for the bridge, type in R ArcGIS bridge, the very first result that appears is for its GitHub page. So this is where the bridge lives. So when you want to get the bridge, all you need to do is simply download it, and believe it or not, you're almost there. If you're curious about what the bridge actually is, we can take a peek at what we have here, and the bridge is just a toolbox. So when you have a project that you say, hey, I think I could really use some help from R, you can go to that project, you can be at any point in your analysis. And in every project, you have a project pane where you can view toolboxes that you have associated with that project. Because the bridge is simply a toolbox, you can select to add it, and then you have the ability to access the tools that it contains within it. Specifically, it has 4 tools, the first of which is the only one you actually need to set up the bridge. The Install R Bindings tool is incredibly simple. As you can see, if you've never installed the bridge before, you can click Run, and it will build the bridge. If you have installed it at some prior point in time, you're not sure, you can just check Overwrite, That'll take care of any existing bridges you've built. Click run, and you're good to go. It's done, it's installed, that's it. I'm not gonna run it because I actually have RStudio open, but this process is incredibly quick. I think it takes like seconds, which is awesome. And once you have it installed, it's installed. So any project you open up, that bridge is still there. You can open RStudio, you can open R, and you can access it, which is great. So let's talk about why I might want to make use of this tool. So here I have crimes that have occurred in San Francisco for 2014. I have performed an emerging hotspot analysis result on them. So what I'm looking at here is I'm trying to get a sense for the spatiotemporal trends in my crime. So what does that mean? That means that I have crimes that are occurring across my map, and essentially I'm looking at locations, which are little hexagon bins on my map, and I'm comparing the crime count for that bin to neighboring bins. And I'm saying, how do they compare? How does this one bin compare to neighboring bins? And how does that compare over time? So this is allowing me to get a sense for where I have locations that have statistically significant increases in crime over time. So for example, these deep red hexagons here. These are locations that I know for a fact that crime over time is increasing, and that trend is statistically significant. Now, why is that relevant? Well, if you're a police department and you want to know what areas you might need more resources to, this is very valuable information. But as anybody knows who works with data, we can't just do one analysis and call ourselves done and say, great, we know the whole story. That's not the case. We often need to dive deep and to figure out other questions and to probe our data to see all that we can learn from it. And one thing we know about crime is that population can play a large role in impacting it. So this result, while great and a good starting point, it's missing some information. I have not factored in population. One thing I might want to do is identify a crime rate. So while I could use the field calculator and do a very simple division, get my crime rate per 100,000 population, maybe I want to do more than that. Maybe I want to make sure that the rates I create are robust. And so this is a great time for me to hop into R and to take advantage of some of the rate smoothing functions that already exist in R that currently don't exist in ArcGIS. So if I want to hop into R, it's quite simple. I'm going to load Esri's ArcGIS binding library. This is just going to confirm, yep, you got the bridge, you got Pro, I know your license, let's go. Esri has functions like ArcOpen, which I'm going to use to simply communicate what am I working with? Where is my project stored? What is the data I'm trying to bring in? And about the data here. It can be in a geodatabase, it can be in a shapefile, it can be in a table. You just need to specify exactly what that data is, where it's located, and you can bring it in. So now we've started to bring in the data, but currently it's in an ArcGIS data type. So ArcSelect is going to do the process of converting it for me into an R data frame object, what Shaun was talking about. And once it's in an R data frame object, I'm good to go. I'm good to roll with pretty much whatever I want or need to do in R. Now there's a couple of nifty things about ArcSelect I just want to highlight. You do have some options here. You can specify specifically what columns you want to be bringing in. I'm personally choosing to bring them all in. You can also craft SQL queries here, which is kind of nice. So if you want just a subset of your data, you can do that. Now, once I have them in, I can just do a little bit of data renaming, and it might actually help if I ran that first command. And once I have that data frame object, like I said, it's an R data frame object, so I'm pretty much good to go. But ArcGIS does me one more solid. We have a function which allows me to convert from that data frame object into a spatial points data frame or spatial polygons data frame, which is great because I have spatial data. And so I don't have to worry about a lot of messy hassle to get it into the format I need. So I can now take advantage of any functionality in R that I want. In particular, what I'm doing is I'm using the eBest function that's going to be performing empirical Bayes smoothing. So what that's doing is it's using population as a measure of confidence for me. Areas with high population are given a higher confidence. Areas with lower population are shifted towards the mean. This is going to help me create rates that are a little more stable. And just like that, it's done. But hopefully you can envision here, it could be any function. You could be doing any type of data aggregation, whatever you need to do. I can simply add it back to my spatial points data frame, and if I'm ready to go back into Pro, I write it back. Now, this is the part that I really get excited about, because I don't know if you've ever hassled with having to transfer data back and forth between different software. It's a pain in the butt. But here is where I decided to write that data to. If I simply click refresh, here it is, crime rates. It's all of that data with those newly calculated empirical-based smoothed rates. I can pull this into my map. I can run it in a tool. I can get back to work. So it's incredibly simple. It communicates very well. And it really opens up your options in terms of functionality.
Awesome. Great. Thanks, Marjean. So, one thing to ask is, if you're going to set up one of these tools, how does it talk, right? What are you going to get if you make a new tool that's an R-based geoprocessing tool? What's going to come in on the R side? And this is kind of a quick table, a quick two-part table here that gives you an answer to that question. So for most of the things, we're just going to take them in as character arrays, just arrays of strings, right? If we send over a coordinate system, we're just going to get back a string that represents that. But for our other data types, we try to do the right thing. We try to, if we have a Boolean, it's going to be a Boolean on the other side. Numeric data, it's going to come across just fine. And that pretty much exists for all the things you're getting across, right? So if you've got an extent, you're going to get back a vector that's going to have the values of the extent. So it's pretty logical. It's pretty easy to understand what you're going to get on the R side. There's a couple ones you might want to know what that is, right? So if you're coming, a folder's coming in, then you're going to get back the full path of the location of that particular folder. But the basic approach is very simple. It basically lets you take things that you would do just normally using maybe Python or using Model Builder. You get to get that directly in R, and you're getting the representation when you make a tool that uses R under the hood. So again, I'm just going to kind of review a little bit of what Marjean just showed you, just to kind of bring it home. But basically, that's all it is from the R side. You just say, I want to use this ArcGIS binding package. Just initialize the connection between ArcGIS and the binding package, and we're good to go from that point on. To open things, you set a data source, and you point at that data source by using arc.open. And then you often want to do some filtering operation, right? You have that input data, but you might want to trim it down. Part of the reason you sometimes want to do this is in R, a data frame is represented in memory, right? So my first time using R, I was working on some global data set. I had 720 million cells. I imported it into R, and then I tried doing a mean, and then R crashed. And it was, it didn't have enough memory on the machine, right? So this is really great because out of the gate, you can say, well, actually, in this case, I'm only interested in these fields, and I'm even only interested in these fields where certain, conditions are met. So at that point, it's nice just as a data model kind of answer, because it means that you're only looking at the things that are relevant to you. It's also nice just from a technical level, because it means that that data frame is not going to take up very much memory. It's going to make things simpler, and that's really handy at times. So now when we've done that, when we've got back this, we've selected into this data frame, like Marjean said, we still got this ArcGIS data frame. It's still in a representation that ArcGIS understands, but is not yet actually an R data frame. And it looks like a data frame, but it always references back to the geometry, right? Because the geometry needs to be encoded in this special way. So to do that final step, like Marjean just showed you, you can use this data to SP call, which is going to take that filtered data frame that we just created and convert it into a fully native R representation. It's both a data frame and it includes the geometry in a way that R understands. Now, any downstream package that depends upon SP can just take that. You can do your work with it. At the end, you can just run this inverse function that goes SP to data and get back another ArcGIS data frame that then you can write out to any ArcGIS data source. So that's the basic workflow. You also, so I mentioned this writing already. You can also use this to overwrite. So you might have circumstances where you want to take that data and you just say, I'm just going to be adding a new column, right? Don't make a new data set for each of these instances. So you can just pass an additional parameter, tell it that it's okay to overwrite, and it'll do that for you as well. There's also a few just kind of convenience functions in the package. Now these deal with some things that if you've ever had to deal with projected coordinate systems, you know that it's not a trivial undertaking. And the internal representation that many R packages use is something called the proj4. It uses this library called proj4. So one of the things we have is we have this built-in set of functions to convert between the well-known text representation that ArcGIS uses and those proj4 strings that you might use elsewhere. So this is very handy. It makes certain kinds of operations simple that can be otherwise hard with R. You also can interact directly with the geometry. Sometimes you don't want to make that data frame, you just want to poke at the geometry. So there's a couple of helper functions for doing that. And there's a couple of things here that if you're using this in the context of a geoprocessing script, you might want to know something about the environment, or you might want to display something. And that's what these tools are for. So there's these two tools, progress position and progress label. So that would be like you're running some script and you want to modify the progressor that shows up on the user's interface, right? So you can do that. You can set the label just using these calls. You also can get access to the environment. If you've used Python before, you're probably familiar with the environment. Currently in the R context, that's only a read-only set of information, right? So you can get back the workspace, the extent. You can't modify the workspace and extent like you can in Python today, but it's something that we definitely have on the roadmap for a future part of this package. Okay, so I'm going to segue for a second here and just talk a little bit about, we've talked about data science, we've talked about R. What does it look like putting those two things together? One of the things that's happened in R in the last about 8 years or so is that this gentleman, Hadley Wickham, who's both a developer at our studio, also a professor at Rice University, he's been prolific. He has made a bunch of really amazing packages. It's actually really grown the R community pretty dramatically. He's done a lot of things that make workflows that already existed much simpler and better. Here I've just shown a plot of some data that I worked on that uses this ggplot2 library, and it's kind of we got this very nice plot out of that, and you know, so we get some confidence interval and we get the outliers all in this nice simple plot. The actual code to make this plot is very simple. It's probably about 3 lines of code, I think. So that's much easier than in most languages. And he's also done a lot of things to make the process of making data manipulation happen and making packages much simpler in R. Things like DeepLiar and dev tools. He also is working right now, if you do anything in Python, the gentleman Wes McKinney created the pandas package. They're working together on a package called Feather that lets you interoperate. I mentioned data frames. There's also the equivalent thing in the Python world called pandas data frames. They're working on a project to allow you to interoperate with that same data structure. So you could have some model that worked in Python, it worked in R, and actually in other languages like Julia, and you could use the same data frame across all those environments. So your backing store in that case would be this data frame, instead of the first step always being converting into a data frame. I mentioned earlier that one of the strengths of using R for statistical analyses is that it has these DSLs, or domain-specific languages. This is just a quick example of that. Typically, if you wanted to make something like specify some formula, you have to come up with this kind of clunky way. In R, because they know something about the domain, they know that you're going to be doing some statistical operations, they can specify that in this very concise way. So in this case, we're creating a linear model. We're going to output it to fit results. And so we've labeled it as a linear model here. That's a function. And then we're going to say that we're making predictions on pollution. And then we have a number of covariates here that are going into that, right? So we're just doing a simple linear model here. In this case, these are purely additive. You also could have terms, you could have interaction terms, and it has a way of specifying that. You can do all kinds of really complicated things. So suddenly you're going into, making a two-way ANOVA with 1 line of code. You just learn what these symbols mean, which isn't too hard, and now you have a very, very concise way of specifying a model, a way that might take many lines of code or many clicks, and if you're using jump or something. There's similar properties like this in other parts of the language that make doing statistical analysis much simpler than it would be in an average programming language. There's also a package named Caret that I think is worth mentioning. It really is trying to deal with this model specification consistency across many, many different packages. I mentioned there's over 6,400 packages in CRAN. They all often take slightly different approaches. So Caret's kind of coming back and saying like, well, can we reformulate these models in a consistent way? So basically you say, okay, I'm going to be using Caret, and then Caret under the hood knows how to talk to all those underlying packages. It's really handy if you are doing work across multiple different packages. Another thing that's kind of emergent is if you saw some of the plenary session, you probably saw the use of Jupyter notebooks. Some of this really goes back to Donald Knuth, who's a very famous computer scientist. He really, he had this idea that you really want to, both for teaching and understanding, you really want an environment where you can have the documentation of the thing that you're working on and the code side by side, right? We often live in a world now where the ultimate realization of our knowledge and understanding is going to be in code, but to get there, it's really helpful if you can have that context right in the same place, right? You can have the formulas, you can have some textual representation, and he's been looking at that for a long time. In some ways, the Jupyter notebook, those things are part of that vision. There's some tools directly in R to really make that easy. There's a way of embedding Markdown along with your Python, with your R code, so you can kind of jump back and forth. You have a document, and it can jump into R, jump back to documenting it. And then Roxygen 2 lets you do some really cool things with documentation, making out LaTeX versions of things. And then Jupyter Notebooks. Yeah? So Jupyter, the word, it used to be called IPython Notebooks a long time ago. Jupyter, the name actually comes from the 3 initial languages it supports, which is Julia, Python, and R. So it's always been there, right? It's always been one of the fundamental languages that they wanted to support was R. And you can use those languages actually together in that context. So it kind of fits nicely into that view of using data science to stitch together multiple languages. Finally, there's also some really good development environments that you can use with R. Marjean was just showing you RStudio. It's great. It's free, and it does a lot of really cool stuff. You can use Jupyter Notebooks, like I mentioned already. That also, Microsoft last year released this R tools for Visual Studio, and that basically means that it's a plugin that's directly in Visual Studio. If you've used Visual Studio before, it knows how to do everything. It provides you a REPL. It knows how to do all the kinds of things that Visual Studio can do. So really, we've got some best-of-class tools for interacting with data that's available to us for working with R, which is really great. And just as an example of one of these kinds of packages, here's something where you could do this kind of operation with data frame, but something like DeepLiar makes this much simpler. So what am I doing here? I've got some data, baseball data, and I'm going to take the batting average information. I'm going to be grouping by a player ID, doing summarization across that, and then sorting it by the total value, and then looking at the top 5 values, right? So, I mean, if you saw on that job chart, right, that SQL is still king. I mean, every environment has SQL. One thing that's kind of happening generally is that people are like, well, I'm fine with SQL, but it takes a lot of time, and I have to talk to my DBA, and it's hard to optimize. So people are looking at how do we make these little kind of domain-specific languages that give us something akin to SQL, but without so much work, right? So this we just wrote in, it's kind of spread out here unnecessarily, but it's basically 5 lines and not really many characters on those lines. To write out this equivalent thing in SQL will probably require some nested queries and maybe some extra joins to go on to get it. It's not trivial to get this in SQL. So this is really nice if we're doing some data analysis in R that's available to us. It makes the data science process much simpler. There are some challenges and tricks that I just wanted to mention. I mentioned that I had this performance issue.
No.
Very careful here. I mentioned that my first experience with R was one in which it crashed, but I still came back to it because it's such a great language. But so it does have some potential performance pitfalls you need to deal with at times, but there's been a lot of work to really make that better. There's only, I'd say, pretty limited areas where you run into that on a regular basis now. Also, the amount of memory people typically have has gone up a lot in the last few years. It's not designed to be a general purpose language. So if I were going to be stranded on a desert island and I could only write in one programming language, I would probably not pick it as my, even though I love it, it can't, if you wanted to do something that had nothing to do with the data analysis and nothing to do with, with an analytical process or statistics, it might not be the right fit, right? Because if you're trying to write a blogging engine, there's not tooling in the ecosystem for making a blogging engine using R. It's not that it's impossible, it's just that you're going to have to, push a rock up a hill to make that happen. It also doesn't have a pure UI-only mode of interaction. If you wanted to make a plot, you can't drag things around and label. It's a typical complaint of environments which are programming first. And in areas, it is kind of a programmer first mentality, right? It's taught typically in grad school when you have many years to learn some, codified set of knowledge. But if you're not in grad school, it can be challenging to take it on, right, as a new thing. There are some things happening like Shiny, which lets you kind of interact with like these interactive widgets that are backed by R, but primarily its model is that you need to be fluent in R in order to use R. Now, that's part of the reason we think this bridge is really great, is that it enables those folks in an organization who have some R experience to share their work with a broader group of people who maybe aren't as familiar with that world. Okay, so now we're going to get a little deeper into the bridge. And what does this look like? It looks like any other geoprocessing tool you've seen, right? So it's just a tool. We've got parameters. We talked there already about how these parameters are going to move between the ArcGIS world and the R world. But when we click that run button, instead of that triggering a Python script or a built-in tool to ArcGIS, it's going to be running an R script. And so with that, I'll hand it off back to Marjean.
Perfect, thank you. So Shaun was kind of hitting it perfectly. So why exactly would we be wanting to wrap our functionality? If you're a developer, your time is incredibly precious. If your organization is anything like ours, everybody wants a piece of your time, and you can't always do that. So if you have functionality in R that's regularly used in your organization, and you want to share it with somebody who's capable of interpreting the results, but maybe not of the scripting end, you can easily craft one of these geoprocessing script tools. Additionally, really the whole point of this R bridge is that we're streamlining your work into whatever platform you prefer. I mean, Shaun really nicely laid out kind of like the 3 categories of users that we're envisioning here. I mean, if you need your work in Pro, you can do that. If you want to get your work in R, you can do that. So let's take a look at one example, and that's the case of you have functionality in R that you regularly use, and you want to make it available to other people who use ArcGIS but are not as comfortable with the scripting language. So a little bit of background. I'm going to be showing you today the scan statistic. It is the most widely used test for detecting clusters. Essentially what it is it's going beyond the question of, is my data clustered, to where specifically is my data clustered. Now, why would you want to do this? So the data I have for you here is from Utah's open data source. They're looking at noxious weed locations in Utah's national parks. And at a national park, they might have limited services, limited park rangers, and if they want to tackle the issues of noxious weeds and trying to reduce them, they want to know, where is the area that I should send people to try and make an impact on this problem? Where is the most potent area for me to start dealing with this and reducing it? So the scan statistic is a great tool for that. And if this is an analysis that they commonly need to run, they can wrap it. So let's dive a little bit deeper into what exactly I mean when I say wrap it. So this is a tool I've created. It entirely calls R functionality, specifically scan.test from SpatStat. If we were to just take a quick peek at exactly what this tool is, it's just like any other script tool except for this one little piece right here. It's not calling a Python file, it's calling R. And that's it. You don't need to have Python to necessarily like a Python package to call your R. It's all being done here through ArcGIS. And if you've ever created a script tool before, this is just the same. You here can customize the UI experience of your script tool. So whoever's using that R functionality, you can kind of control what it is that they see and they do. You have the ability to give them different parameter options that might have specific selections if you want them to choose particular parts of the data, or perhaps if you want to give them model options, Poisson or binomial. You can specify defaults if there's certain values that you think are important for them to consider first. You can also specialize or specify symbology, so you can really customize how these results appear. The tool itself looks like just any other normal geoprocessing tool. And so when you share it with someone, this is what they see. And when they want it to work, they click run. So let's look at the R side of this. This is the script that is actually being called right now by this tool, this very thing right here. And what is exactly wrapping our functionality? What is that? It starts out pretty simple. It's really just a function with some in params and some outs. This is kind of what you can think of as the template for any tool you're going to wrap. You're going to follow this same format, this same function with in params and out params. We can take advantage of some functionality Shaun mentioned. In the bridge, we have a lot of different functions that kind of enable you to craft these tools. One of them is arc.env, so you can read those environments, get a sense for what your user has. If there's something that you see as a potential issue, you can print out a message to warn them about certain things. Here, you can do some simple work of making sure that whoever is running your tool has all the R packages that they need. So this is just simply doing a very simple check to say, hey, do you actually have this package? If not, let's install it into your library. So that way, when I do actually call them and load them, I make sure you have them. Anything that the user is putting in that UI as parameters, you can index. And once they're indexed, you're good to use them in your script however you want to do that. So it's really like, these are just kind of the finer points of setting it up, but once it's set up, you're free to start roaming with your coding and get as creative as you want to get. So these are the various things that a user's inputting for me. So that data set they're giving me, that's just what I'm calling it, my occurrence data set. I can specify that selection by agency because I'm picking that national park they've picked, and I can use that throughout my coding. Now, the last kind of setup part, if you will, is taking advantage of the bridge to actually get that data in. So how does this tool work? It's entirely utilizing the bridge. Those same functions I showed you, ArcOpen, ArcSelect, ArcData to SP, that's where we're taking that occurrence data set that they gave us in that tool, we're opening it, we're taking the selection they gave us, they specified an agency for us when they ran that tool. I'm using ArcSelect to bring in that specific national park they wanted. I'm then converting it to, in this case, an SP object, and then I'm converting it to a point process, because that's what I'm going to need for my scan test function. And here, just as Shaun mentioned, I am customizing that experience. So you're not seeing the tool run, because that's not quite as exciting. But here, I am customizing what's printing out for them when they're watching the tool run. So it's giving them notifications to let them know what progress it's at and how it's doing. So now here, this is you. This is all you. You can get as complicated or as simple as you want. This example is quite simple. Just because all I'm doing is I'm calling the scan test function. And that's all I'm interested to do. But you're open here to be creative and to customize and to take advantage of our functionality however you need to for your organization, which is incredibly powerful. With so many different libraries and functions, there's really, in my mind, almost limitless possibilities for how you can create these tools and what you can get them to do. Now, I am doing something here that I personally like. I am crafting some messages for the user of my tool, and I'll show you what that looks like in the UI. But all I'm really doing is just printing results, so that way they have it. They're not just getting something in their map, they're also getting information that's printing out for them when they run it. And lastly is something a little bit sneaky. We are still working on raster support. We know, we've heard you, you want it. And that's something that we are actively working to get developed for you. But this particular function is actually going to output a raster for me of the likelihood ratio test statistic. And since the bridge doesn't quite work with raster just yet, I can take advantage of other R functions to actually do that for me. So when I'm writing my result, I'm actually using write raster as well to put that raster input into my project. So yay. So let's take a look. Here it is. Hey. So here is the result. So really, just to kind of drive it home, here was the original. Obviously, we can see there's clusters, but if I wanted to try and pinpoint it a little bit further, this is giving me a map that's helping me to do that. Additionally, I mentioned my messages here. And so this is all just stuff that I've crafted as I was running that tool. So I'm printing out for them exactly what that scan.test function found. They get their p-value. They learn some information about exactly how it went, how the data looked, and they have a result beautifully symbolized in their map that they can take advantage of just by clicking run. They have no idea that any of that's going on, but it is. And you can craft it to do what you need it to do, which is incredibly powerful.
Awesome, great. So yeah, just to wrap up here, we've talked already about how to install it. There's just some details. There's some instructions online to get you into this, get started using it tomorrow. It's really easy. Where can you run this is a question that we get sometimes. So if you have a really old version of ArcGIS Desktop, it's not supported. 10.3.1 was the first version which we implemented this bridge, and we also implemented it Pro 1.1. The only thing that's a little tricky here is if you're in desktop still, if you install R, you get two versions. You get a 32-bit version and a 64-bit version. ArcMap is a 32-bit version application, so you have to use the 32-bit version of R to talk to it. It's just something to be aware of.
And RStudio has a 32-bit version as well that comes with it. So you can just switch it and it works great.
Yeah, exactly. If you're using Pro, then you can just use 64-bit versions of both. You also can use the background geoprocessing mechanism in desktop to get you into the 64-bit version. If you had something where you had memory limitations, you really needed the 64-bit version of R, you can do it in desktop as well. So you can run it now. You need to get R, get either Pro or ArcMap, and you can use it in a variety of contexts. This also works on the server side. So on 10.3.1 and later, it works on the server. You can use this for running geoprocessing services. It's really not too hard to get it going. What's next? We are looking at now implementing Conda for actually managing these environments. I kind of talked about this idea of you might have a problem where you need to chain together different languages, so we're looking at trying to make that even easier. So at Pro 2.0, you can install R just like any other package. You can install the R bridge just like any other package using Conda. We really want to look at how can we make that workflow even better than it will be in 2.0 in the future. And as Marjean mentioned, we do not support raster now. Now the good thing is that, like Marjean just showed you, it might not always be necessary, right? So one of the things that's different between feature data and raster data is that if your backing store is really just a geotiff, then R knows how to work with geotiffs, we know how to work with geotiffs, that's fine, right? Where we definitely need to add raster support is in more complicated cases, like if you're working with a mosaic data set, or you have raster data stored in an SDE instance, then there's things that we need to do to make those kinds of workflows enabled, because that's not possible today in R. But yeah, something that we're working on actively and will deliver sometime this year. Okay, I mentioned that we have a resources section here. I want to leave at least 1 or 2 minutes for questions, but just quickly I'll jump. So we've got a few. Do you want to drive here? Is that going to be easier, do you think?
You can actually just switch back to mine.
Over to you?
Yeah.
Okay.
So real quick, one thing we've gotten asked for a lot is, this looks cool, but where the heck can I have some resources to actually get up and running with this besides just watching you lovely people? So I've been working really hard over the past couple months to create some of these for you. Hopefully you find them useful, but please feel free to give feedback on what you need, because that is entirely what I've been dedicating part of my job to, is creating these. So we have 2 brand new web courses. They just came out. We have one on using the R ArcGIS bridge. That's the basics of getting set up, of reading and writing your data, and getting comfortable with that workflow. We have another one entirely about wrapping script tools. So you want to wrap? Awesome. Hopefully you're talented. But if not, we have a web course for you where you can learn the basics of doing that. It shows you the template script, and it gets you all the steps for getting up with that. We also have a learn lesson that we've put out, and it's kind of to help you get an idea of how powerful the bridge is. So it's a workflow using some tools in ArcGIS and some tools in R, and just how well they seamlessly are integrated to expand your capabilities. We also have the R vignette. So if you want to know more about the functions in our package, we have written it up, so that way you can get an idea of all the functionality that is included with them, even some gems that we've left out due to time. So.
Great. All right, so in the interest of time, I'm not going to go through these resources, but there's a lot of stuff in here you might want to look over. There's other sessions, there's some details about using R. The task views are amazing. If you have a specific problem, check out the task views. They really get you pretty far fast. Some background on using it with data science, a few other things. Yeah, there's a lot going on. Just to close out, one of the things is that this is really a community-oriented project. R is open source. It's a little different than just a strict vendor relationship, right? You can take this R, use it in other contexts. So really take a look at it and kind of think of it in that community context. And with that, I'll just say thanks to all of the folks who worked on this, and thank you to Marjean. And we'll take any questions, I think, up at the front. We're out of time, so I don't want to make people wait. If you have iOS or Android, please give us a review. If you don't have that, then I will accept an Acadian tablet. And that's it for today. Thank you.